Let's discuss solve problem 2 on single linked list. Consider a single linked list where f and l are pointers to the first and last elements respectively of the linked list. The time for performing which of the given operations depends on the length of the linked list. So this is the linked list available in front of us and the options are also available. We need to identify the correct option. Okay. This question has been asked in ISRO CS 2014. I would encourage you to pause the video for a while and try to answer this question on your own. I hope you're done. Okay, let's move on to the solution. What is the meaning of this statement? The time for performing which of the given operations depends on the length of the linked list. Here the statement means which of the given operations has order of n time complexity. If there are n nodes in the list. Let us suppose we have n nodes in the list. Now the question is saying the time for performing which of the given operation depends on the length of the linked list. If there are n nodes in the list, this means the length of the linked list is n. And the time for performing which of the given operation depends on the length of the linked list means which of the given operations has order of n time complexity. Here I am considering the length of the linked list is n. That is why the question is asking us to find the operation which has order of n time complexity. Now let's discuss option A first. And let's see whether this operation takes order of n time complexity or not. The operation is delete the first element of the list. Let's see how much time this particular operation will take. If we want to delete the first element of the list, we can easily delete it using f pointer, but we need another pointer t as well. Because we have to move our f pointer towards right, so that it can point to this particular node. Because after deleting this node becomes the new node of the list. That is why f must point to the second node of this list. Now we can easily move our f pointer towards right by using this line of code, that is f equal to f link. We can't do this without using t pointer. Okay, there must be some temporary pointer available which must point to the first node of the list. So here f pointer is now pointing to the second node of the list. Now we can use t pointer to delete the first node of the list. Here it is very simple. We just have to write this line of code, that is free t. And then you can easily understand the time complexity is just big O of 1. Here there is no traversal involved. That is why the time complexity for deleting the first element of the list is just big O of 1. So it is clear that option A is not the correct option because we have to find out the operation which is depending on the length of the linked list. Now let's discuss option B, that is interchange the first two elements of the list. Let's see what happens when we interchange the first two elements of the list. Obviously we need another pointer, that is t pointer, which must point to the second node of the list. Now here what we will do, we will just interchange the two elements, Here we will just interchange the first two nodes. In order to interchange the first two nodes, we have to make changes in their link part. Okay. Here the first node must point to the third node and second node must point to the first node. That is what we will do. And in this way, we would be able to interchange the first two elements of the list. Very simple, isn't that so? Here, first we will update the link part of the first node. That is f link equal to t link. This makes this first node point to the third node of the list. And after that, we will just update the link part of the second node by using this line of code, that is t link equal to f. In this way, this particular node will point to the first node of the list. After this, the resultant list looks like this. Here the first node becomes the second node and second node becomes the first node. But yes, we have to update our f pointer so that it can point to the first node of this list. Therefore, this line of code is also required, that is f equal to t. In this way, the f pointer will point to the first node of the list. You can see these three lines of code will take constant amount of time. Hence, the time complexity is again big O of 1. So it is clear that option B is also not the correct option. Let's see whether option C is the correct option or not. That is deleting the last element of the list. Let's see how much time is required to delete the last element of the list. We can definitely use L pointer to delete the last element of the list, Of course, we can use this pointer to delete the last element of the list by just writing this line of code, that is free L. After deleting, obviously we will lose the reference to the second last element because after deletion, the L pointer is now pointing to nothing. Here it must point to the second last element of the list, but after deleting the last element of the list, we lose the reference to the second last element. The pointer L must point to the second last element after deleting the last element of the list. Therefore, it is necessary to keep a pointer that will traverse the linked list until the end node is reached. Now here traversal is required, so it is clear that this will take order of n time. Let us see the code for traversing the list. Here we need a t pointer which must point to the first node of the list, and then we will use this traversal procedure so that this t pointer will eventually point to the second last node of the list. That is why in while loop, we are checking this condition, is t link equal to null? If it is the case, we'll get outside of this loop. Otherwise, we'll continue. So with this traversal procedure, eventually t pointer will point to the second last node of the list, because here you can see that t link becomes null. So it stops here. And then after that, we'll use these 3 lines of codes. We'll free the last node, and then after that, we'll update the L pointer so that it can point to the second last node of the list. And then after that, we will make the link part of this node null. That is what we are doing here. In this way, we would be able to delete the last element of the list. You can understand that we can easily delete the last node of the list using L pointer, but we cannot lose the reference to the second last node of the list. We must have the reference to the second last node of the list, so that after deleting the last node, L pointer must point to the second last node of the list. Therefore, it is important to traverse the list, and that is why we are keeping a t pointer so that it can point to the second last node of the list. With the help of t pointer, we will update our L pointer. This operation will take order of n time because of this traversal procedure. So, deleting the last element of the list actually depends on the length of the list. So it is clear that option C is the correct option. But let's see option D as well, whether it takes constant amount of time or not. That is adding an element at the end of the list. We can use L pointer to add the element at the end of the list. It is very simple. We'll create a new node, and then after that we can use this line of code to update the link part of this node. That is L link equal to T. Now this particular node will point to this node. After this, we will update this L pointer so that it can point to the new node. And that's it. Adding an element at the end of the list is very simple, isn't that so? Here, the time complexity is also big O of 1. So, it is clear that option C is straight away the correct option.